You may begin.
Okay, we're going to go ahead and get started. My name is Jennifer Dill. I'm a faculty member in the School of Urban Studies and Planning, and I co-organized this seminar with Robert Bertini, who will, I think, be here shortly. And anyway, so today we have with us one of our MERP alums, Mauricio LeClerc, who's going to be talking about bicycle commuting in the Portland area. And this was largely research from his field area paper, though he just informed me he's been doing a little more work on it. He's currently also working at Portland Department of Transportation, doing additional work there. And then I also want to remind everyone that when you ask questions, to hold down, like I am doing right now, on the touch button of the microphone while you're speaking, so we can make sure that the people out in webland and people who watch this on the archives after the fact can hear. So without further ado, I'm going to turn it over to Mauricio.
Well, thank you. Thank you for coming. I've been sitting in that section of the room many times, and I've enjoyed many presentations, so I'm happy that I can contribute a little bit. We'll get started, but first I'll tell a little bit about myself. I came to the United States in 1989. I'm originally from Chile, Santiago, Chile, which is population 5 million, and I lived in a very busy part of town full of transit lines and several, major intersections. And I moved to Corvallis, which is population 40,000 at the time. So that was kind of the worst culture shock, was just moving from a big town to a little town instead of just moving to the United States, which I find I just fit in perfectly. So without further ado, I'll just talk about bicycle planning in the city of Portland, but mainly about the statistical analysis between the relationship between the city's bicycle network and bicycle commuting. I'll give a brief overview, the evaluation of the 1998 City of Portland Bicycle Master Plan, and the 5-year update. That'll take the least amount of time, and then is the bicycle commute and mode share in Portland. And then the larger part of the time will be dedicated to the regression analysis that I did. So, yeah, it's a little lesson there. So, this is from the city of Portland. What makes a good city for bicycling, and it's also applicable to pedestrian as a mode of transportation. And the first one is that urban design be oriented to people rather than autos. I'm not going to elaborate on them. Traffic calming, you need you need people to feel safe if they're going to use non-auto modes in transportation. Stricter enforcement of traffic regulations. That's the case in Santiago, where you had all the elements of a good pedestrian and bicycle system. You can just move around if you wanted to, but only the pedestrian one was used, because bicycle in Chile, it's very unsafe. There's very lack of education, And then restrictions on automobile use, and I won't elaborate on that. And just move on to the 5 key elements that the 1998 Bicycle Master Plan identified. And those were policies and objectives, bicycle network, and provide end-of-trip facilities, improve the bicycle transit link, and promote bicycling through education and encouragement. I'll mention a little bit about, mention a little bit about that. The policies and objectives, we all are familiar to the state requirements. The state has a bicycle and pedestrian plan. Metro has the Metro 2040 plan encourages pedestrian and bicycle activities and trips, and trying to balance the transportation system and so forth. And same with the city, has one of the oldest bicycle programs, and the Bicycle Advisory Committee, and the Bicycle Plan. And then the Transportation System Plan, which was adopted in 2002, very recently, also has some important things to say about bicycle. So then the bicycle network, that's something that will be very important for this discussion, is the variable, if you can say, that that I use for my statistical analysis. Then provide end-of-trip facilities. I mentioned this to put my study into context, that it takes more than just the built environment to get people to travel. You need to affect all these variables, all these elements to make it safe and convenient for people to move around using the bicycle. So provide parking. You need to find a place to park wherever you go, wherever you want to go. And then improve the bicycle transit link. That's also the elements that the city identified, and promote bicycling through education and encouragement. I can say that in terms of bicycle parking, where did I put the number? Oh, there's been 2,500 bicycle parking racks installed and 350 lockers. Since that's in the 5-year update done by Roger Geller, the bicycle coordinator, and then oh yeah, in the city, and Roger has been hired as a bicycle coordinator, and there was a person before him, and he is very busy being in all sorts of transportation issues, and in that encouragement, promotion, safety concerns, and also planning, how bicycle relates to planning. And he also coordinates the Bicycle Advisory Committee, which is made of residents appointed by the City Council to counsel on bicycle-related activities. And so here's an example that bicycle safety has been, improving as the crash rate has declined. Basically, the number of crashes, if you can see the little dots, have remained about steady at about 160 crashes a year. But as the number of bicyclists has increased, and you can see that I think these are pedestrian bicycle counts at the Hawthorne Bridge. And as the number of crashes remains stable and the number of bicycle trips increases, then the crash rate decreases, and that's a positive sign. All the benchmarks are headed in the right direction, and some are perhaps a bit slower than others, but the city is moving in the right direction, and the policies are being fulfilled. What's next? And one of them is bicycle ridership and bicycle commute. In terms of just ridership trips, the accounts, the bridge counts identified that from the 90s to the 2001, there has been a 143% increase in trips, and that's much greater than the population growth that we've experienced in the city. And a section of that would be bicycle commuters, and that's what I'll be talking about, because that's the information that the U.S. Census provides and records. And ask the question, I'll talk about that now. Usually at around April, people that do the census, I walk around and ask people all sorts of things. Ask about the usual means of transportation during that week. And did they record, whether it was the usual, not what was yesterday's, because it makes a difference. I think we can talk about it at the end of the presentation. And so it may depend on the weather. If it's really nasty out, you may have a different turnout, different numbers. So to talk about a little bit, I wish I could move. Perhaps I will. Just pay attention to the yellow line. The mode split has increased from 1.1 in 1990 to 1.7 in 96. Actually, that's using the American Community Survey, which is it's apples to apples, but not quite. Maybe green apples and red apples, but it's pretty close. And then finally, the year 2000 is the 1.8 mode split. So it's been increasing. The numbers don't seem radical, but remember that that's just 9% of all bicycle trips. So you had, in 1990, you had 2,500 cycle commuters, and in 2000 you had 4,800. And now at the bottom, if you can read, again focus on the yellow part, we'll compare the difference between the increase in bicycle commuters, which is at the top row with the increase in the bicycle network at the last row. As you can see, if you can just pay attention to the very right side corner here, that there has been a 90% increase, almost doubling of bicycle commuters in 10 years, and the network has expanded by 2.5 times. So that's kind of like what we'll test in the statistical analysis, whether there's a relationship between the two. Now, bicycle commute in Portland related to major United States cities, and we're number 3 among 64 major cities. In the Minneapolis and Sacramento are a little bit ahead of us, and if you notice, that's a different number that I just gave you. So probably there are different ways of calculating depending on whether you had a census tract here or there, or whether it was just bicycle trips. So we'll leave that aside for now, but we're 3rd. And it's in this one is around a little bit over 2.5, and that's still below the benchmark the city of Portland, the master plan had set for for the city. The city wanted a citywide mode split for bicycles of about 3% and 5% in the inner city. So we're a bit behind by both counts, the ones I've been giving you, but we're moving ahead. Now, a little bit of literature review. I won't go into detail, but just reading around for my field area paper, I noticed the case of Europe. We'll know that in certain European countries have very high mode split for bicycles, and it was I just listed some of the elements that may influence that, and the same may be true for American cities, and that some of them don't seem to have much of a difference, like weather or city size, or even density, which is kind of controversial. We can talk a little bit more about it. And others do seem to provide a more solid relationship with bicycle commute. That's safety and education, and the political will that's very important to implement safety and education measures, and to build the infrastructure. And that I put north versus south here because if you know, certain countries such as certain cities in certain countries such as the Netherlands, Sweden, and Germany have a high mode split for bicycles, and in some cases has increased rapidly, whereas in other areas of Europe, like Italy, France, the mode split is much lower. And it's interesting because some of the cities have the same densities, and the weather, you can say it's better, meaning warmer, less rain days and so forth, but they just don't have the mode split. So you can say it has a lot to do with political will, the advocacy. We want this, or other situations such as the traffic conditions that you may be experiencing there, the gas tax and so forth. So that's. And the John, do you pronounce the name Pucher? Okay, he's a good source for that to study European cities. And in case of American cities, the most important ones that I've came across was the 1992 and 1994 National Walking and Bicycle Studies, and then the Nelson and Allen study, and the Adele and Carr, that's who are right here with us. So we're lucky. That the Dylan Carr, it's evaluation, and in my opinion, an improvement over the Nelson and Allen, which basically took American cities and just set up a whole bunch of different variables and tested them statistically to see whether they had an effect on bicycle commute. And in both cases, the Nelson and Allen and the Dylan Carr studies, as well as the conclusions of the National Walking and Bicycle Studies, says that the bicycle facilities and infrastructures do have an influence on bicycle commute. So with that said, it all seems in the right direction to test the hypothesis. So we're doing pretty good with times. We have a pretty good amount of time to dedicate it to questions, I hope. Here's the bicycle network from 1989 to 1999. I used those numbers because I used the census for 1990, 1996, and 2000. So I didn't want to use the year 1990, which because the census is usually early in the year. So I used the previous year, 1989, for the U.S. for the 1990 census. Yes.
Mauricio, for the bicycle network, are you determining just on-street facilities?
Yeah.
Okay. So bicycle lanes only.
I think that comes next. I don't have a clear view of what's next, but yeah, I'll talk about that. And actually, I'll talk about it now. Maybe we can get it out of the way. I just included here the bicycle lanes and the boulevards, not the share lanes, which is another category, and the off-street, the trails, for example. Because we're talking about commuting to work. I don't think I would take, I could go to a park and then come back to go to work. So we just remove them from the data. So that's why it's less miles. Usually it's more miles. We have about 240 miles of bicycle facilities in the city, but I only counted about 145 of them. So you can see the colors. Let's see, the city looks pinkish, and the bicycle network in 1989, it's in green. That's where it was built. And then red was in 1995, additional on top of what's already there in 1989. And then the big jump in number of miles was between 1995 and 1999, which is shown in blue here. So, and you can see you can perhaps see a pattern that there seem to be more lanes and more boulevards in the central city, and we'll see that later. We'll see why. Anyways, it's 115 new miles or a 256% increase. And now the network, I already talked about that. Shoulder bikeways are just a white line next to a road with a wider shoulder, which a bicyclist and cars can just pull over. But it can be used by bicycles. I didn't include those, and I didn't include the off-street paths, as I already said, but I did include bicycle lanes, which you see now, and bicycle boulevards, which are, actually I'll go back a little bit. Bicycle lanes are usually used for more direct routes in more heavily used arterials. So you have perhaps capacity constraints. So you separate lanes to provide a sense of safety, and also it serves, some claims serves as a traffic calming device, as it seems to give the perception that the road is narrow. So and the boulevards are usually what I try to use before I get to a major intersection in which there's conveniently a bicycle lane that will get me across the bridge. And you see there that it's treated specially, and they are in areas of town. Sometimes they are one street off of a major intersection, like Ankeny. So you don't have to ride on Burnside, you ride on Ankeny. Or in other cases, the one I used was Salmon, because I lived in a Sunnyside neighborhood area. And that's in the middle of between Belmont and Hawthorne, and just cruise down. I like that because you can get to work very fast in the morning. And on the way back, it was but I would use then I would use Yamhill, which I found to be the flatter street. So if you guys in the summer want to go back and it's kind of hot, you want to get sweaty, you just use Yamhill. Okay. You have to go around the school, but it's up to you. Anyways, they're treated with traffic circles and street and signage. You can see bike route, and also signage is a very important aspect of it, and it's not included in the study. But it's very important. And the whole point is that you have two ways to move around, and perhaps they have to do with, different trips call for different treatment, bicycle lanes or bicycle commutes. But for this study, we combined them. We didn't separate them. You can do that later. Maybe I can keep on studying this if somebody pays for it. So here's the 1990 bicycle commute. 45 miles. That's what it was in 1989. And you can see that it's concentrated mainly towards the central city. I put as ground zero the Pioneer Courthouse Square, and I did a 4-mile buffer around it, as I saw Roger Geller do, and I thought that was appropriate. Yes?
you might want to. Oh, not that. You might want to think about excluding the bike paths. I happen to commute on a bike path, and
You mean on a...
like the Willamette Greenway.
Okay, yes.
And now that the east side is open, there's a lot of people from Selwood using that.
Okay.
The other thing is the focus on just commuting to work. That kind of excludes kids who are legitimately going to school.
Right. Yeah.
You know, it's not fluffy recreation.
Yeah,
That's what their business is to go to school.
I'll explain those two. I only used bicycle lanes and boulevards and excluded the trails just to be conservative. I didn't want to just the main reason. And I just assumed, sometimes you gotta assume that, I included it, I don't include it, but just to be conservative, I didn't. And the second one is, you're totally right. Commuters are just 9% of all bicycle trips. I said that, and it's very important to get kids to school on bicycle. I did that whenever I could. But the U.S. Census only asks that question. Where do you get, how did you get to, what was the usual way to work for this week? So that's the data that I had to work with. So that's why we're only talking about bicycle commutes today, and that was the focus of my studies. So 1990, 45 miles. Oh yeah, and you want to guess what was the track, the census track? The neighborhood where the census track with the highest commute mode share was. You can kind of see it.
Where you live?
No, that's Sunnyside. It's a little bit. I used to live right here. But I just moved there. Yeah, it's the no. Okay, you got to know your neighborhoods.
Buckman and
It was Hosford Abernathy, the Lads Edition area. I just moved there in that area, and it had an 11.2. I mean, it was track 11.02, and it had a mode split of 6.3. And at the time, there were 38. Let's go back a little bit. We had 45 miles, and we had 38 tracks with no riders. Okay. 1996, we had 72 miles, and you want to guess? I guess it's pretty obvious. The downtown, it has the highest commute there, and it had 19.7. And the number of tracks, so now 75 miles, and the number of tracks with no riders, and then 0% bicycle commutes, decreased to 25. Okay, and again, all center around the central city, around Pioneer Courthouse Square, following what Roger did. And then 160 miles, that's in 2000, only of the boulevards and bike lanes. And you can see it start to get darker. The bicycle commute starts to get more intense. Now you get to darker numbers, which mean higher commutes, higher percentage commutes. And the highest one, anybody want to guess? Elliott neighborhood. I think I spelled it right, but it looks wrong. That's 23.2, and it's just I cannot get over that because the previous ones it was practically zero. I don't know what happened. Maybe Roger can explain, but the maybe the steel bridge has something to do with it. The new East Bank Esplanade or so forth. But again, the important thing for me is that the number of tracks with no riders decreased to 21. So you can say the bicycle network miles increased throughout the city, and the number of tracks with 0% bicycle commuters has decreased. So now that moves us to the regression equation, which is the boring little equation there. I just wanted to put it because it have 34 independent variables. And the sources of information were the Portland Office of Transportation, the bicycle network, and the data was provided by Roger, who came in. And the 1990-2000 U.S. Census and the 1996 American Community Survey. And that was done at the census tract level. And for the GIS sort of thing, the Geographic Information Systems, we used the Metro's RLIS. I think it stands for Regional Land Inventory System, Survey, something like that. So that's the variables. It's impossible to read. Maybe you can. It's not not needed. I just can say that they're basically divided into three sorts. One of them is the physical ones, meaning slope, elevation, the network itself. Then you have social ones, social demographic ones, such as age, kids, poverty, medium household income, and so forth. There are actually a lot more. You can run them straight, or you can turn them into percentage. And the last one would be the transportation ones that came from the U.S. Census, mode split and commute times and all other modes, transit commuters and auto commuters and so forth. Number of vehicles per commuter and percentage of households with no vehicle and so forth. So here's an example one, population density. In 1990, the mean for all the tracks, this is different, is 6,000. That's way higher than what the overall citywide is, and that has to do with how tracks are divided. The larger the number, the smaller it gets, so it kind of biases the numbers towards a higher mean. So population density has increased in the city in the last 10 years, from 6,000 to 6,200, and the average citywide is about 4,000 persons per square mile. So that's how I recorded. And again, it's also surrounded. It goes around pretty close in the inner city, within a 4-mile range. Elevation was another one that I used, and here I'm going to show you because there are many ways of going about it, and there is no magic, and sometimes you have to make a decision based on the best data that you have. And in this case, here's a 3D image of the city of Portland. It's very hilly on the southwest side, and also you have Mount Tabor here and some of the hills towards Clackamas. So that may have an influence on how steep they are, or what the elevation is, may have an influence on how far down or up you want to travel. So I used for that a contour elevation, contour maps, contour lines, per track. And what I did was had to do a very time-consuming thing of just cookie cutting, which means just getting all the contour lines within a track, 10 lines, each one was 100 feet, 110 feet, 120 feet, and just got the mean out of those. So I had to repeat the whole process 145 times to get, but there are other ways to go about it. This is the method that I chose. And that gave me one variable. You can see that another one would be slope, and that's also provided by the GIS RLIS, or perhaps the City of Portland data. And so I use 5% to 10% slope, 11 to 15, 16 to 20, 21 to 25, and 26 and over. And what I did was just get the centroid for the census tract, which you can get by downloading the XTools script on the Esri website. And just run it. Gives you a little center here, which are in green. And then I just went and said, okay, where's in what kind of slope is the centroid located? And that was the basis for that variable. And as you can see, it's a mostly flat area between 5 and 10 percentage slope. And that happens to be the area where most of the bicycle commuters are. So there may be a relationship there. And another one, which is also took me a long time to figure out, was the jobs near census tracts, in that we just did a 5-mile buffer around the census tract. Again, we used the centroids, and then that was instead of census tract. Actually, I used the census tract to figure it out, to assign the value, but then I used the TAZs, the traffic analysis zones that the Metro provides, and it has employment, retail, non-retail, and households and population. So. And I tried to approximate the years with the years that I've studied. And the 5-mile buffer has to do with the little chart on the right side. It gives you the cumulative percentage, bicycle commuters as the miles increases. And you can see that it remains fairly low until you hit about 1 or 2 miles distance, and then it starts to grow, and then it tapers off again at about, 5 or maybe 7 miles. So you have this, what would be a cube function, I think. And so 70% of bicycle commuters travel distances of 3 miles or less, and 80% of bicycle commuters travel distances of 5 miles or less. So we just used to capture more jobs, 5-mile buffer. So I had to repeat the whole thing. The yellow one would be, you use the GIS to, here's the census tract that I used, and I capture all those census tracts where you could potentially commute to. So that's a way to go about it, to see if any sort of a job-housing balance would play into the equation. Again, the bicycle network, we already saw that. And I already mentioned that I didn't go through the whole list of variables, but I will mention that some of them were correlated. That means that they were related amongst themselves. And you don't want to have that in a statistical analysis because it just biases the whole thing. And I'll just show you the ones that I found they were correlated and removed them. Usually you just leave one and remove the others. And the age categories, for example, they were correlated among themselves, and that was just a rule of if the relationship was 0.6 or higher, it would be highly correlated, so I just removed them from the model. Slope and average elevation were related. You can see that. And another one was percentage persons in poverty and households with no vehicle. That was also correlated, and usually I tended to leave the households with no vehicle in. And finally, the median household income and persons with college degree. That also tends to be correlated. The higher the income, the higher the college degree. The higher the poverty level, the higher the percentage of households with no vehicle in a census tract, and so forth. So let's get on to the results. This is year 1990. The R-square, which measures the performance of the whole system, was 3.321. It's not terrifically exciting, but I wasn't out to prove, what totally makes the change, what really makes bicycle commute. I just wanted to prove whether bicycle lanes per square mile had an influence, adjusting for other variables, and that's what the regression does. You have the regression analysis does two things, at least for me, other than gives me headaches. First, it finds a relationship between two sets of data. One could be amount of paper that you use at home, and the other one could be bicycle commute. They don't even have to have a theory behind. So that's why you have to have the theory, the economic theory, the transportation theory to make sense out of that. So imagine you just have the amount of paper you used on one column, and then that would be 1, 2, 3, 4, 5. Each person 1, 2, 3, 4, 5. Each track 1, 2, 3, 4, 5. And then you have bicycle commute be 2, 4, 6, 8, 10. And then you put them together, and the machine will tell you that there is a relationship that for every one person that uses paper, there's 2 commuters. And you can say, hey, now 2 papers, 4 commuters, and so forth. It may not make sense, but that's what the model will tell you. So that's one of the things. And the other one would be that it isolates one. Like population density may have an influence on bicycle commute, but also could be another variable. And maybe population density is hiding other things, like distance to CBD. You can see from the maps that the area near the downtown, near the river, is the area where it has the most density. It also is the area where it has the shorter distance to downtown. So how do you isolate those? You put them in a regression, and basically it adjusts for the other. It holds things constant. Yes?
One quick question about the density.
About the what?
The density.
Okay.
When I was looking at the map, the zones where you showed the highest bike mode split seemed to be white on the density chart, which would be the lowest density category.
Say that again, I'm sorry.
You had a graphic that showed the density of each zone in a color, and the white category was the lowest density.
Yeah.
And it seemed like the close in, like the downtown and the zone right south of 84, where you showed that 23% mode split. So what you're saying here is that higher density increases mode split, but what you were showing on the graphic was the opposite.
Kurt's neighborhood and Elliott neighborhood both had white, meaning the lowest density.
No, I don't think so.
There might be a couple exceptions here.
No, it's we had time to go back, I think. Yeah, I mean that's the regression just proves that I'm not saying that it's perfect, and actually you go back and you'll see that it's perfect on the east side. If you move to yeah, that's right. You may say that that's perhaps where the central east side is. Some of the industrial areas won't have mini commuters. It's true. I mean that's why we're testing it in a regression. But it seems that within the 4-mile buffer, there seem to be, that's where the higher census tracts with the higher bicycle commuters. But if you notice in the hills, there's 0 to 1, I think. Well, that's a population actually. And actually, bicycle commuters, it's about the same. Not very many commuters here, lots of commuters on this side. So that's what we want to try to sort out. I'm not saying anything, I'm just saying that seems to be a general trend. And actually, that's a good point. Because sometimes a map here won't give you a clear picture. We need to test it. And actually, the regression may not, be perfect. It's not perfect either. You need to test it and triangulate if you can. So I'm not claiming that this is the answer. It's just an approach. Yes.
I don't know if this answers the question, but that's population per square mile. And I know Elliott neighborhood was one of the places that had a lot of bicycle commuters per population.
Mm-hmm.
So if the population of the whole census tract is 199 people,
Right. Right.
If the census tract is big,
Right.
that may describe the
Yeah,
difference.
exactly. There are many variables. That's a good point. And actually, also the areas outside of the city they tend to have greater tracts and lower people. So it's kind of disproportionate. Suddenly they just fall out. The density is really low. But on the other hand, when an area gets too dense, then a tract splits into two. Otherwise, it would be crazy. So there are some things you need to adjust for those, and you need to understand. So those are. Thank you for the questions. So where were we? I think we're right there. So number of census tracts at the time was 141. That's what the N represents. And if you can just pay attention to where the arrows are, bicycle lanes per square mile. Actually, you need to pay attention to two things here. Forget about the T statistic. Forget about the beta, where it says in the standard error, just focus on the B, which, and that's the coefficient. It tells you how much influence that this variable has on the dependent variable, which is bicycle commuters. And but the most important one, where you usually start, is at the right-hand corner, the significance. So that's the p-values, and you want to get those as low as possible. That means the probability that the result, the influence of a certain variable on the dependent would be due to chance. So, for example, distance to CBD has a 0.000, which means that there's zero probability that relationship would happen randomly. It has to be there's something in it for sure. And traditionally, it's in journals and so forth studies. You want to have a p-value of a 90% or better. 95, it would be optimal. So in this case, it would be being 0.05 or lower. And for the 90%, would be below 0.1. Okay. So bicycle lanes per square mile meets that criteria, and so does the constant and the distance to CBD. To CBD, the central business district, the downtown, and slope at the centroid, which was a variable that becomes very important later, but in this case, it wasn't significant. So you just forget about it. You just leave it in the model, because everything you take and put in changes the outcome, of the relationship between the numbers. It's like a recipe. It may be this variable may make the soup too salty, but in with other variables it's just right. So it's kind of an interesting play of numbers. So another warning that this is not the answer to all the questions that you have out there. What else I want to say? The households with no vehicle was not significant, and neither was slope at centroid. And the caption at the bottom perhaps is the most important, that an additional 1,000 feet of bikeways is associated with a 0.035% increase in bicycle commute mode share. Other things equal. That's another aspect of the regression. Other things equal, this would happen. That turns out to be about 100 feet of bikeways is associated with about, I think it's 17 new bicycle commuters. The city built 100 new feet of bikeways, and suddenly they would show up another 17 bicycle commuters. I'm not saying that it causes it, and that's something you need to be careful. You cannot claim that it causes it. Yes?
Just to be clear, that's feet per square mile.
Yeah. And the other one is that, geez, I forgot. Oh, and that the numbers seem very low, because two things. Because bicycle lanes are in feet. You make it into miles, and suddenly the number grows bigger. Here, actually, they are in 100 feet. But at the bottom, I put them in 1,000 feet. So that's why there's 1 0 less 0, 0.035. And here is 0.003512. And the other one is that we're talking on the dependent. The dependent variable is it's a percentage. So you change a 1% change can mean that means a lot of people. If instead of bicycle commuters in percentage you had the actual number 4,800, maybe these numbers would be much higher, because it would be an additional 1,000 feet of bikeways. It's associated with 17. Instead of having the 0.0035, you would just have 17 point something, and so forth. Any questions? No? We're going to move through about 6 of those, so I know it can be tedious, but I'm doing my best. Now, in the 1996, what we can say is that bicycle lanes per square mile, again, is significant in this case at the 90% confidence level. And an additional 1,000 feet of bikeways associated with 0.060 percentage increase in bicycle commute mode share, other things equal. Households with no cars, again, is not significant, but distance to CBD is, and slope at the centroid is also. Actually, something that I forgot on the previous one is that you got to look also not only at the coefficient but at the signs. Let's go over it again. If you have a positive sign, like bicycle lanes per square mile, that means that there's a positive relationship. The more bicycle lanes, the more the bicycle percentage commuters. And population density in this case proves to be significant, and positive, though small. The higher the population density, the higher the percentage bicycle commuters, and so forth. Distance to CBD, which is a very strong variable, is negative, meaning the farther away, the longer the distance between the downtown and where you live, census tract, the less the census tract, the less bicycle commuters it has. The closer to the downtown, the higher the bicycle commute rate. Okay? So here, again, the sign it's as we expected for the bicycle lanes per square mile. It's a 0.060 percentage increase in bicycle commute mode share, other things equal. And the distance to CBD is also right. The higher the distance, the lower the mode share. And slope of centroid is also significant in this case, and it means that the steeper the slope, the less the bicycle commute, other things equal. And the households with no cars. Population density in this case is not significant, and it has the wrong sign. Notice that? Something interesting. Or perhaps not interesting. And in the year 2000, let's go through the most important again, the bicycle lanes per square mile. It is significant, and it has the right sign, and it means that an additional 1,000 feet of bikeways per square mile is associated with 0.037% increase in bicycle commute mode share, other things equal. And population density is significant, but it has the wrong sign, meaning the higher the population density, the lower the bicycle commute. And distance to CBD, it's very significant, and with the right sign. It's a negative relationship. And so is slope at centroid, and households with no vehicle is significant finally, and has the right sign, meaning 1% increase in percentage households with no vehicle in a census tract is associated, well, for the whole city, is associated with a 0.036 percentage increase in bicycle commute, other things equal.
I'm sorry, I forgot what you said about the correlation between population density and distance to CBD.
Oh, yeah.
You kept them both in your...
Well, I kept them both to adjust, one adjust for the other, so nobody can... If, for example, if I remove distance to CBD from the equation, then it's very likely, I don't remember exactly, that population density would prove significant, because it's actually, you can see that a lot of it is in, a lot of the bicycle commuters are are close to downtown. But so therefore you ask yourself, but maybe it's because of the distance, the location, not the density. That's why you include both, to keep one separate from the other. And and that's what it is. In this case, it's a negative relationship, which is interesting. But it's something to talk about, because the cities in the United States with the higher mode share are not the ones that have the highest density necessarily. So, and the R square was 0.333, and there were two census tracts that split, so the number now is 145. So as a summary, more bicycle facilities are associated with more bicycle riders. People living closer to downtown are more likely to commute by bicycle. The third one is the density seems to be less important than location as a determinant of bicycle commute. That may be a little bit generous. I'm just could not find any kind of relationship whatsoever. Density was significant, not significant, positive, not negative, and so forth. And the fourth one is that steeper slopes are associated with less bicycle commutes. And asterisk, and we'll read the note, and it says average elevation was also associated with less bicycle commutes. That's because they were correlated, but if you substitute one for the other, usually elevation would also be significant and have the relationship that you expect. And finally, lower car ownership is associated with more bicycle commutes. Even though it wasn't that strong, I think actually the persons in poverty was a stronger relationship. So those are the things, the kind of conclusions that we can get from doing a regression analysis for the city of Portland for the years 1996 and 2000. It doesn't leave that room, basically. That's where the study ends. You can extrapolate, but that's not my purpose here. And ceteris paribus means holding things constant. So I just gotta keep reminding folks. Other things equal, actually. And now I have that was basically my FAP in about an hour, and now I added to it. Jennifer and I really wanted to work on connectivity measures and see if those had any relationship with the bicycle commute. And the computer just crashed on me. Some variables were really hard to, time consuming. So I just had to leave them out, unfortunately. But now that I had the opportunity to be here, I brought him back in. Actually, I forgot to mention that City of Portland was chosen several times as #1 bicycle city in the country and in the North America. So, and that's the magazine that proves the whole thing. That I'm not lying. Okay. So are we back in business? Yeah. So this is a work that I did with Shimon and Paul Bender, Shimon Israel, who's now in the Bay Area, for the Portland Office of Transportation, where I work and he worked, measuring performance measures to be used for the transportation system plan. And they're actually implemented, that's a performance measure. And again, as with any kind of geographic information system question you have, there are many ways to skin a cat. And we just did 3 measures. One was the density of nodes, the link to node ratio, which is the number of intersections divided by the network, the amount of roads. And finally, the length of the block face. You can see that the first one is a kind of a grid pattern that the city promotes, because it's fine-grained, you can move around easily, you can distribute trips and traffic easier through the whole system rather than have the other system, which is what the lollipop system, where you have a lot of cul-de-sacs and large blocks and few four-way intersections, and it acts more like a watershed in which you have little creeks feeding into a larger stream, which would be the highways and the barber boulevards and so forth. And connectivity is a street system with many alternative routes and connections serving the same origins and destinations. And here's a comparison. The central city, you can see, I guess that's Burnside, and you can see how the street pattern deviates. Here you have the links, here you have the nodes. The nodes are in green. And here you have the far southeast, which was before annexation, built usually before annexation to the city of Portland. You can see a lot of cul-de-sacs and lollipops. The lollipops are in red, and the actual intersections are in green. So we had to measure those. An example was for the central city intersections per square mile was 0.52. Link to node ratio was 1.62, and percentage blocks less than 570 was 75%. That's 77%, and the 570 feet block measure was something that Metro came up. It's not set in stone, but it seems to be pretty standard for cities around the country. So the way we did it, and actually Shimon Israel based his field paper on this work, and his work was integrated, as I said before, into the transportation system plan. And so I used his numbers, not the ones that we did with Paul Bender and Shimon. And they're divided into 8 transportation element districts, which are defined along major highways and the river, geographic features. So basically, if a census tract was in southwest, I would assign the value of that we came up, the connectivity value that we came up for that district. As you can see, they're pretty big, and there are better ways to do it. Perhaps we can talk about it. Maybe you can just shrink the geographic size to be more precise. What's the actual connectivity in this area, not the whole district. So as an example, it's pretty labor-intensive too. Here's Lat's addition with all the blocks, and then on the right side you have the blocks only the blocks that are less than 570 feet in block face. So all the long block faces are removed from the model, and then you run it. And here are the new regression results, and the ones to keep in mind are the ones in the arrows again. In the bikeways per square mile again is significant. It's pretty good number there, and that's positively associated with the dependent variable, which again is bicycle commuters. So the higher, an additional 1,000 or 100 feet of per square mile of bikeways would be associated with 0.0046% increase in bicycle commutes, and again that would be about 25 new commuters. You put 1,000 new feet of bikeways, you get suddenly, not causation. Again, I cannot talk about causation, but it's associated with 20-some new bike commuters. Other things equal. Let's see. Density again was significant, but with the wrong sign. And the distance to CBD was significant again, and with the right sign. Slope at the centroid was not significant, and the most important one for this case would be the link to node ratio, which meant that it's significant and it's positive, meaning the more intersections an area has, the higher the bike commute. Okay, other things equal. Now we'll move to another year 2001 for the block face. Again, the bike length variable is significant, and the sign is as expected. The density is again, as the other one, significant, but with the wrong sign or unexpected sign. Distance to CBD remains steady. Slope at centroid becomes significant now, and the one at the bottom, the most important for this one, is significant again, and with the right sign. So another variable that it seems to have a positive relationship and association with the dependent variable. And finally, for this new regression results, the year 2000, the number of intersections per square mile. And you can see we can just go back at the very bottom that, again, is significant. Actually, it's better than the other ones in terms of significance. And the coefficient is positive and with the right sign. So it seems like for the year 2000 model, connectivity measures do seem to make a difference in bicycle commutes, other things equal. Having said that, and the bicycle network variable was significant also once you introduce the new variable into the old model. Now, for the year 1990, the block face less than 570 feet was significant and with expected sign, but not the other ones. And the bicycle network was significant, blah, blah, blah. Year 1996, none of the connectivity variables was significant. So you draw your own conclusions. And but the bicycle network variable was significant and with expected sign on all studies. Actually, I did a fourth one for the previous one, which included all the variables. Like I put 1990, 1996, and 2000 into just one spreadsheet, which to see what happens. To see, it kind of tests the variation over time. If the numbers of 1990 are totally wacky compared to 96 and the 2000, there would be problems. But all the coefficients were about the same as before, so it kind of proves that the model is stable over time. There are many other ways you can do a regression analysis and also come up with the variables. So I didn't include it because it may not be that important. So to conclude, because I really want to get into the questions that I know you'll have many, I hope. So I just can take notes. And is that the city of Portland, the conclusion is that it's done a remarkable job promoting bicycle and implemented the bicycle plan. But it has a tough challenge in several aspects, and the most important one is the finance part of it. There are two things. One is the funded part, the more realistic plan, and this is the dream. What if you had a lot of money? Well, if you really would like to make a difference, a real, extreme case, that would be the total number of miles, which is, as you can see, from this study, bikeways seem to be associated with bicycle commutes. So you would want to keep on building them, so you could, because for some reason, safety perception or convenience, there seems to be more bicycle commuters out there using the system. But the problem is that to build a whole system would be $140 million, and that's old dollars. It could be much more. So it's something to keep in mind, that we've made a terrific effort, but it's going to be a challenge ahead, politically and as well as financially, to keep the network expanding at the rate that we did during the late 90s, for example. A lot has to do with the networks that are in areas that are hard to build, like the Southwest, steep slopes and narrow right-of-ways in which you may have to expand and build more expensive facilities to accommodate all the different modes. So that's something that I'll leave you with. But other than that, I want to leave you with a happy. So that's 382 miles need to be added, I think. I don't know. And finally, I want to leave you with a happy note. So thank you very much. And that's me over there. So I'll take any questions. Thank you very much. Yes.
I'm thinking, this is more a comment than a question, in terms of the density variable.
Yeah, that's good.
And I'm just speculating here, and we'll have to look at the data more.
Mm-hmm.
But I'm guessing that if previous research showed that density was positively related to bicycle commuting, I think what your findings are showing is that it isn't the density that was causing that. It was slope and connectivity, because I would guess that the denser areas are more likely to have well-connected streets and are more likely to be flat, and it's those variables that are positively associated. And density itself actually might truly have a negative impact on bicycling if that might mean more car traffic, for example.
Right.
So I think your findings at the end would support that theory.
Yeah, that's a very good point. And it's the denser areas in cities around the world usually tend to be the older areas, the older parts of town, and the older parts of town tend to be the 100 prime spot. You come to the new world, you find the flatter area closest to a good wider system, and you can move around and you build them. You don't have the cars. Everything gets built in a smaller scale that you would find today in many areas in the United States. So it's true. Also, the capacity constraints, I think I was talking with Dave Hampton, and he bikes in northwest, and some of the intersections can be a challenge to cross because you have so many activities going on. You just cannot have a straight line. Other than that, so having said that, there may be other reasons, and I have my own theories, but is your question related to density?
Well, intersections.
Okay.
Yeah, I'm just curious about the finding that there is a positive relationship between bike commuting and the number of intersections. I mean, I think the number of intersections may suggest some sort of urban form, but I mean, as a bicyclist, I'm not always that crazy about intersections. I'd rather be kind of more free flowing,
Right.
as would I would assume cars or other kinds of traffic too. So, do you have any thoughts on that?
Yeah, but I'm not going to share them with you. No. Well, there are, of course, one thing is the built environment, the actual street. Another one is, traffic mitigations. The bicycle network is pretty good about giving signage and preference to bicycles. That's the whole thing about traffic circles, and bicycles. At least me, I don't like red lights. I just like to keep going, and that's why I take salmon and just go and just fly down the hill. And those are things that are important. But having a well-connected street network doesn't necessarily mean gridlock if you have a good traffic system management, I think. And yes?
Just to go back to that Boise neighborhood example again real quick.
Are you from Boise?
I live in Elliott.
Elliott, okay.
Did I say Boise?
Yeah.
I think the example was Elliott neighborhood.
Yeah.
I live in Boise, which is right across the street. But I know that neighborhood and some of the other east side neighborhoods, or I should say census tracts that you were looking at, have some residential and a lot of industrial. And so that made the population density look low. And then there was a lot of commuters there, so that maybe showed that there's not a connection, but really the density is high because all the population is only in one portion of the census tract.
That's right.
So maybe
that's
looking at population density in a different way, like excluding all lands that are not residential.
Yeah, that's a very good point. I'll write it down. They're all good points, by the way. Just yours is actually... No, I'm just kidding. So exclude non-residential zones, areas zoned for this.
Simply to figure out residential
that's
density.
Very good.
Not just building density, but
Exclude
residential density.
non-res. Okay. Any other questions? Yeah, Dave? Press the button there.
Is there any way that you can measure traffic congestion and correlate your bicycle commuting rates to the traffic congestion?
Probably. If you
probably talk to Tom Jensen.
With a $40,000 budget, I can do it.
Well, no. I mean, just take a look in your TAZs. Maybe there is a traffic congestion
Perhaps.
variable.
Yeah.
And because a lot of what you had on the map there are in the areas that are heavily congested, people react to the congestion by looking for alternative forms, such as transit or bike.
That's what it's all about. It's how you balance, depending on the trip distance, the trip purpose, and so forth. You balance whether you, especially in a country like ours, that has people are affluent. Many of the commuters, most of the commuters, do have cars, and they have the money to use the bus system. A lot of it is preference. And that's something to talk about. Whether the chicken and egg thing, what comes first? The political will to build a network because there are so many bicyclists that want to use a system, or because you build a system, suddenly people decide, hey, I want to give bicycle a chance because this seems like a very direct and safe way to move around. That's a fair issue. So traffic, the way I looked at it was that bicycle, I wanted to just do it without traffic because I never care about traffic, the actual numbers of traffic. And actually, I didn't really care about crashes very much. I think it's the perception of safety that people really jump. Nobody really knows, the accident rate in a certain intersection, and nobody really knows the traffic counts. You can just kind of guess high, low, medium. It's whether you feel safe moving around. And I think bicycle lanes provide that to me, and I assume that perhaps it provides to other people but of course, that could be a wonderful variable to include. Yes, Robert first.
Actually, an email question, and it says, regarding the lack of positive population density correlation, is it possible that increased transit offerings available in dense areas account for that? If so, I would like to see a comparison of costs of reducing congestion via bikes to via transit.
Ooh, that'd be pretty exciting. Of course, the city would try not to put those in competition, but they are always in competition. I mean, all modes compete for each other, and what I was saying is that perhaps in a denser area, and if you go back to, do you remember that chart that had the bicycle commutes, the percentage cumulative? Suddenly for short distances there was very few bicycle commuters, and suddenly at about 1 mile started to go up, and then taper off at about 7 to 15 miles. Perhaps, that's a speculation again. For short distances, the bicycle is competing with walking, and walking is winning. Perhaps, And in medium range, bicycle wins. In longer range, longer distances, transit and car may be winning out over. So there's a kind of a niche for bicyclists that would be between 2 and 5 miles, in which bicycle can be a really, it performs better compared to the others. So that's a good point. But I'm not going to go into the other aspect because that's a political issue. The cost things, when you start talking, it's actually, I do think that I would Roger may say something, but it seems like it would seem like a cost-effective way, just to add traffic circles and the bike lanes to an area. But again, it all depends, of course, on the number of commuters that you get, because it's cost per commuter, cost per user, so. It's kind of outside of the scope of this project, but it's a good question. Any other? Teresa, of course. I'm sorry.
I was just wondering, it seems like you combined your bike boulevards and bike lanes into one variable bike infrastructure. I was wondering if you ran your regression on just the bike boulevards and the bike lanes.
I didn't, and I know you did, and I think Nelson and Ellen did, but I don't know why not. I think we just decided, Jennifer and I, that just to run them straight. I could do the same. It would just give me twice. I mean, I ran so many regressions, 20 dozens, so it doesn't really matter. It's just that to show them it would be kind of cumbersome. But we could do it, yeah.
I guess the reason I asked is if there could be any policy implications from that. Like, I don't know the cost to put in a bike lane versus a bike boulevard, but if one is more effective than the other, maybe that would.
That study would cost you $2,500. He'll do it, yeah.
Just follow up to that, though. What share of the bike network was bike boulevards? Are there enough bike boulevards to do that analysis?
That brings another very good point. I'm not going to forget it. And I don't know. I think I'm going to be guessing because I already forgot the number. Perhaps boulevards are around 1/3 of all the system. Is that the ratio? Lower. Yeah. So that's something that I wanted to talk about, because what happens when you get a lot of zeros? A lot of zeros in your data set can create a problem. Running what we did was an ordinary least square regression. Then you need to start finding other variables and running a different type, like log variables and natural log system and multinomial regressions and so forth. So that's a good point. That's why I have more confidence in the year 2000 data than in the 1990, because in 1990 you had a lot more tracks with zero values, and also a lot of census tracts with no bicycle network at all. So a lot of zeros. I'm not too comfortable, even though for Professor Dill and Professor Strathman the data set was okay. We didn't have to run anything special. I did run some log stuff, but it just messes up. It fixes one thing, but it ruins another one. So I just said I just want to run a clean regression and see what happens instead of just trying to manipulate, massage the data so much. Yes?
I was just wondering what the exact definition of a bike boulevard is.
I have written the exact. Well, I have the exact one. Okay, quote, a bicycle boulevard is a shared roadway. Bicycles and motor vehicles share the space without marked bicycle lanes where the through movement of bicycles is given priority over motor vehicle travel on a local street. Traffic calming devices are used to control traffic speeds and discourage through trips by motor vehicles. Traffic control devices are designed to limit conflicts between automobiles and bicycles in favor bicycle movement on the boulevard street. That's the definition. Yes.
Do you know what year TriMet started putting bike racks on the buses and what role that might have played in increased bike use, or is that something you can test?
Yeah, I have no idea. You'd be interesting though. Yeah, Charles.
You showed a graph that the bicycle safety is improving in the beginning of the presentation.
Yeah. I mean, the crash rate has decreased, which is a way you go about measure that. There are maybe other ways, but that's
the decrease in collisions.
Yeah, that's from the city of Portland. Yes.
What's the main reason for that?
Who?
Or what are reasons for that?
Education. I mean, there's the education on parts of the bicyclist. Wear the helmet, sign. Use your hand movements and so forth. Another one is the other side, is the other modes, education on the other side of it. And then also can be as more bicyclists are on the road, people are more aware of them, people get more used to them, and so there's a period of adjustments. I'm just trying to guess. Maybe some other folks may want to add to that, but that's kind of what I would guess. And also, of course, promotion, education, going out and talking to folks, teaching them at school, signage, better signage. And the city is working on a cool project that you're going to see pretty cool signs coming up in the near future. So
yeah, I was thinking it's because there's more riders on the road.
Yeah,
so people are more
and also there's a learning curve. As time goes on, you learn what the problems are and how to fix them.
If there's no more questions, I'm gonna make an announcement.
Okay, I just wanted to say one more thing about density. Is that it's not just density; it's also the diversity of uses. Because you can have a very dense residential area, but if all the jobs and all the attractions are really somewhere else, you're not going to bike. So it's just the diversity of uses that also creates, because you need to think of the trip end. And what's the other side of it? Trip beginning, trip. The origin. I'm sorry. Yes, the origin and the trip and the destination. And they had to be in close proximity, and they had to be in a way related to make it work. Just one kind of density and one kind of use may not cut it. And the other one that I just wanted to say that too, because that may be also a variable why density is not kicking in, or why it doesn't just.
And I wanted to, we are considering offering a bicycle pedestrian planning class in fall 2003. So this upcoming fall. And I have a sign-up sheet here, not to sign up for the class, but if you are interested in this class, I'd like to sort of gauge interest, and also if it is offered, send out an email when we know it is going to be offered to let you know about it. So if you're interested in that, I'll have the sheet here. You can sign up. And then I want to thank Mauricio for his presentation.
Thank you very much. Actually, I do have, for those who stay, take a look at this one. That's from population density, and the higher numbers are kind of towards the low. It's kind of interesting chart. Food for thought, I guess.
Is your footer done?
Yeah.
Can we take a look at it? Because for a workshop project, we're doing